Hey everyone, welcome to the Tom's Hardware Podcast for today, March 12th, 2024. As always, I'm Tom's Hardware Editor-in-Chief, Avram Piltch, joined by Associate Editor Les Pounder, and our very special guest, Jo, aka Concretedog, who is here to talk to us about his robot kit. So, Jo, can you tell everybody a bit about more about yourself?
Hey, so yeah, I'm Jo, aka Concretedog. I kind of make all my living, not that it's enormous, from making stuff and writing about it. So I write regularly for Hackspace magazine. I've been running a long sort of KeyCAD series there. I do a bit of comms work for the FreeCAD, the FreeCAD Project Association. So yeah, I'm kind of full time in kind of making stuff and writing about it. But the project is called StoRPer, and it's a little open source modular kind of robot that you can build up in lots of different ways, and it's built around a PCB that I've developed, and I'm selling on my Tindy, and it's all a bit of a blur. I launched it last Friday as a little project. I had about 50 in stock, and it went a bit crazy. I sold out in 5 days, and yeah, I've got another fabrication run on the go at the moment, and yeah, it's all been quite a bonkers week, really.
I do like StoRPer. It reminds me of the old Pololu robot chassis, like the tiny little sumo robots.
Yeah, the sumo, that was a classic little bot, wasn't it? It's yeah, in some ways, I mean, that's kind of where I started with robots, was that kind of stuff. And but the origins of this project are actually, because I'm quite old, and so I've called it StoRPer, which is a play on words, because when I was a kid, there was this American toy by Schrader called StoRPer, which was it was the first four-wheel drive little car, and it wasn't remote control, it wasn't anything like you could, it just literally went forwards, and it was like low ratio, high torque, took 1 AA battery, and I loved it because it would just, like, you could get it to climb over your hand, and you could test out how steep you could kind of get it to go up things and stuff like that. So yeah, when it came to designing this little robot, I was like, that was kind of my influence. I was like, it's got to be kind of little and talky and stuff, which exactly like you say, those Pololu sumos and stuff are exactly that. Yeah.
Oh, I love it. I mean, you've got a really nice compact PCB. You put some thought into it as well. So it's got a Pico on the PCB. What else has it got?
So it's pretty straightforward. If I hold this one up, it's literally, there's just a there's a place for the Pico. So I'm selling it as just the board with the headers, and that you can solder in yourself. And then basically you've got 4 little motor drivers, which is the L9110S, which is a perfectly good, but a kind of, yeah, classic kind of cheap and cheerful kind of motor driver. Those are all 4 of them are wired back to the Pico. The reason why there's 4 is because I kind of want it to, you can build it up in a sort of mechanism style, and of course for mechanism you want to do 1 driver per motor per wheel. So yeah, 4 of those. There's a way to externally power it, or you can drive the motor straight off the USB supply into the Pico if you're using the little N20 gearbox motors. I've got this hole here. Oh, I can't point on my camera. There we go. This hole here that's slightly larger, I'm just dubbing the really useful hole. And the idea being that if you've got sort of stuff routed about on the back, and you know, maybe like you've got an encoder or 2 on the motor and you want to run it up through the stack, then it's really useful to kind of have a hole to run it up through. And then yeah, the rest of the pins are broken out in this main sort of connector here, and then a few more on this connector here. And the idea is that you can and there's some mount holes. So, but the idea is that with this connector at the front, down the line, I can do kind of maybe some other PCB designs for people, so that we've got PCBs that connect to that connector but come out of the front, and maybe have like kind of sensors and stuff like that on the front of them. But also it's open source, so anybody can design to it and add stuff and knock yourselves out with it.
So do you have a preferred parts list for how a person could make exactly what you're holding in terms of the mechanism wheels, the motors, the power source, that plate? Is that 3D printed or something that you buy?
Yeah, so at the moment I'm selling the PCB on its own with the headers. I've got options to sell these laser cut, what I'm referring to as decks. And there's a couple of different types of those that directly fit on top of the PCB. But I'm not kind of selling the whole thing, because I want it to be kind of modular and I want people to have choices. And I also, one of the aims with it is I want it to be kind of affordable for people. So if you have access to a laser cutter at your school or your makerspace or hackspace, and maybe a 3D printer, then, for example, like, you know, these, I've published the files for the motor mounts for N20 motors that will mount directly to the PCB. So print your own, you know, save stuff getting posted around the world. You can produce it locally. And the same with like all the source files for the upper decks are kind of there, and the source files for the PCB design are all there. So yeah, the simplest way to kind of build it would be to kind of buy some wheels like the Pololu wheels, buy 4 N20 geared motors, and then you know, add your own Pico, add some motor mounts that you can print, and perhaps, you know, add a deck, either of your own or bought off me. But then even then, I thought that might be too expensive, and people have got 3D printers. So I've actually done a wheel design, which is a little PLA cord wheel, and then a TPU tire. So again, if people have got a 3D printer, you don't need to kind of you know, buy a set of wheels, because like the Mechanim wheels, these are commercial Mechanim wheels. They're really good. Places like Pimeroni sell them, but they're kind of like maybe 20 quid a set. I'm not quite sure, but they're probably around that mark, because they're, you know, they're pretty technical kind of little products with lots of parts. But also loads of the other commercial wheels will fit. The Pimeroni wheels that they sell for lots of stuff, as we said, the Pololu wheels, they'll all kind of work. So yeah, on the repo, there's a little kind of basic list of how you can get started, but then kind of we can build off it and we can do all kinds of stuff with it.
So how are you powering it? What are you using for the power source?
Again, loads of different options. So if you're using 4 of the N20 motors, they're such low current draw that you can just stick like I've got a little DIY USB power pack that I actually made that out of some 3D printed bits at a vape cell and a couple of cheap boards. But any USB power bank and feed the USB straight into the Pico, it will drive the motors quite happily. Other options are you can supply up to 5.5 volts into a sort of diode protected power input. There's a couple of pins that I've put on the PCB, and you can directly kind of go into there. So like a nice option is this one has an AA battery holder, but it won't run off an AA. But an AA battery holder will hold one of those 14500 LiPo cells, which are like a sort of small 18650. So it's a single cell. But it'll you know, run between like 3.7 and 4.2 volts and stuff like that, and that runs it kind of perfectly. So that's a really simple way to just, you know, no power conditioning, a battery and 2 wires straight into the PCB. You might want to put a switch in, but yeah, you're off to the races. Or if you want to kind of, you know, be a bit more posh about it, I've got some suggestions about you could use like a variable buck boost DC to DC at a LiPo cell and stuff like that. So again, trying to give other people the options. So if your only option is, I'm going to say a UK thing now, just for Les, if the only option local to you is like a Poundland power bank, that's perfect. But if you've got a few bits and bobs in your electronic supply, like maybe some DC to DC stuff, there are other options you could explore as well.
That's very cool.
That's great. I mean, I think one thing though is I think it's definitely good to suggest power banks to people, because it's not as easy as it might always seem to find a USB power bank that's the right size that you can mount. A lot of them are just not made for like being used this way. So, you know, you have a power bank that's like, it's too big, it's too heavy, it's too round. So it's not always a given that it's easy to find like a really good, you know, rechargeable power bank. And then some of those other things like 18650s can be a little bit volatile. So powering these things I find is always part of the challenge, is trying to make sure you have a battery that you can easily mount. Because it's not, and it's not so heavy that it will like mess up the the balance. And
yeah, that's kind of part of the fun, I think. So, like, even with the little 14500 cells on it, it makes a huge difference which end you put the battery on if you're running it over sort of uneven ground and stuff. And so there's kind of learning fun there as well as
Also, when you're shopping around on, say, Amazon, for example, and you're looking for like a power bank, a lot of times they don't really tell you the output voltage. Or they don't tell you the voltage. They don't tell you the amperage, right?
Yeah.
So they'll say, "Oh yeah, this has, I don't know, 30,000 milliamp or so, 5,000 milliamp hour battery." But what they won't tell you is like, "Oh yeah, this actually only outputs like 500 milliamps from the port or 1 amp or something, and you needed 2 or 3 or something." So, like it's.
So if you're building this with 4 N20 motors, the N20 motors are such low draw that sort of the lowest possible thing that would meet old USB specs. So like anything up to 500 milliamps would have enough, even as the motors start, and if they all start at the same time, it's not going to have an inrush that pulls it over 500 milliamps with the N20s, which is kind of handy. But yeah, I agree. And like it's a kind of minefield as well about. Like that. I'm pretty sure I've had USB power banks that have stated, we're 10,000 milliamps. And it's like, well, why do you only charge my phone halfway before running out?
Right. Yeah. It's not like it's not a great field for robot makers, right? It's most of those things are designed for phone charging. Some of them don't even necessarily stay on consistently. Like they'll turn themselves off to save power.
Yeah.
So
if the current draw is so low, it just says there's nothing there. I'm going to turn off.
Yeah.
There's been some brilliant videos recently, hasn't there, about that? I know Great Scott's Gadgets did one where he used the 555 to like create a little kind of interrupt pulse that just kept his power bank alive. And then what's he called? Andreas Spice, the Swiss guy, was like, I love Great Scott, but I could do it much better. And so there was like a kind of back and forth between them about like more increasingly sort of efficient and technical, wonderful ways to keep your USB power bank alive.
Right. I love there's a 555 way of doing it because everything can be run from a 555. We know that. But I mean, you could use a resistor. Just bung a resistor in to pull it up all the time. Very inefficient, but it's like a penny for a resistor.
Yeah. Do you remember those? I think, Les, I remember talking to you about them. There was a great, before like all the kind of pine sills came along, there was a great really cheap USB soldering iron that everybody used. And inside it had this motion switch that was like a spring, a really loose spring inside a little metal canister. And it was tiny. And then whenever you kind of moved it, it would make contact and it would reset the kind of timer. But it would always turn off my power bank. So I remember a great hack was to like, pull it open and pull that spring off and just solder across so that it was constantly on. Yeah,
I remember that was the original $4 USB soldering iron.
Amazing.
It claimed 8 watts. It never was 8 watts, but it did the job. It worked.
Absolutely, yeah.
But going back to your robot, I want to talk about this. You've got breakouts for the GPIO. So can we, feasibly put sensors on the board somewhere like ultrasonics, that sort of thing?
Absolutely, yeah. And I haven't kind of got around to designing this myself, but we've got a whole heap of kind of GPIOs at the front here, and we've got ground and VSys, so system power. I've laid it out in a way you can't really see perhaps on my NAF camera, but if you look on the key card on the repo, there's I've even made it so that if you made a connector for this, you couldn't accidentally reverse it power wise by laying the power pins out kind of in that nice diagonal thing where if you flip the all of that's kind of at the front of the robot. And I also like the idea of we could do kind of sort of sensor mounts that come down off the bottom of that connector, but could also come out above the stack. So there's numerous ways that we can explore where those sensors sit and what we do with that is it's going to be fun to explore, I hope.
I like as well how you've got headers on there for a Pico, which also means we can use a Pico W. So if we want to put Wi-Fi or Bluetooth on, ready to go.
Absolutely. If I'm 100% honest with you, it was one of the things that I wanted to do before release, but I've got a million projects on, and I had sat on a box of these knocking about under my desk, and I thought, I just need to get this out, and then maybe somebody else who's bought one of the first 50 will put up an example of using the Pico W. But yeah, wireless would be ideal for this. Really interesting. One of the first people who bought one, I kind of can't show you because he hasn't given me permission, but he's putting on the I forget what it's called, but it's like the ESP in the Pico format board. It's like an ESP32, but it's in the footprint of a Raspberry Pi Pico. And there's the whole ROS, the robot operating system. So there's a whole ROS2 kind of stack of firmware that can go on that. So yeah, I mean, that's incredibly exciting that somebody's jumped to that level of complexity with it straight away.
I like that. It's what hackers do, isn't it? We get the technology and we mess around with it and make it do different things. In this case, ESP32, which is a hell of a good microcontroller. Yeah,
absolutely.
Yeah. So, I mean, that's really impressive. It's very affordable. It says right now it's out of stock on Tindy. When can folks expect to be able to order it again?
Yeah, so I put it up a week, not last Friday, the Friday before, and it sold out the first kind of, it was just short of 50 units in sort of 6 days. And as it was kind of getting low, I thought, oh, okay. So I've put another order in. So there's another 75 coming. Hopefully they'll get shipped in the next couple of days to me. So maybe another 5 or 6 days, and we'll have stock. Because of course, when they arrive, I've got to kind of package them up, de-panel them, package them up, put stickers in. Everybody gets a sticker, of course. And also kind of making all the other bits of stock, like the if people want to buy decks and if people want to buy motor mounts. So I've got most of that on the go. So it shouldn't be too long when I receive the fabricated kind of boards. Yeah. So hopefully, 5-6 days, week. I'd like them to be there. But I've got about 50 people on the wait list, which Tindy does as well. So I probably need to order another batch before I even start selling the next batch, maybe.
That's fantastic. Is this your first Tindy project?
No. So in full disclosure, I write for Tindy. I write for the Tindy blog. And as part of that, a few years ago, I started my own shop, and I put up a few rocketry related kind of bits and bobs. Nothing major, nothing very expensive, little problems that I'd solved for my own rocketry that maybe other people would have a use for. But this is by far my most sort of successful Tindy products. I've sold stuff in, odd couple of orders a month of random things to people up until now. And then, as I say, last week was just kind of nuts. It was like, it was my full-time job last week, pretty much.
Yeah.
Well, you mentioned rocketry. So do you have, to hand any suitable props on rocketry that you could show us?
Of course. I'm always surrounded. Well, actually, I realized I'm underneath a massive rocket that's so big. I have to kind of put it on these massive hooks in the roof in our end room to store it. I mean, this is one of my favorite rockets. This is called Panzer. This is a scratch-built rocket that I designed for my first high-power rocket flight. And then this is, like StoRPer is open source. I never sold this, but this is a rocket called ODR, which is an open development rocket. And it's all open source. There's like a repository of the design for this rocket up there. So, yeah, it's I haven't actually done much this last year because of weather and time and stuff like that. But, it's a big hobby. And a good way to burn what little money you have.
Have you sent any Raspberry Pis up in the rockets?
Do you know what? I don't think I. Oh no, there was somebody put a Raspberry Pi in one of my rockets, a Raspberry Pi Zero, to test out a little. They'd built a little camera rig with like launch detection. So with the big rockets, they quite often sit on the pad for a long time whilst we're waiting for airspace to clear and we're waiting for like coordination and the systems to kind of allow us to launch it to be ready. And they were doing this experiment because they found out lots of if you put an action camera on it, it sometimes runs out of memory or runs out of battery, or you end up with like a an hour and a half kind of video by the time you retrieve the rocket, but you only want that middle 40 seconds. So he built a Raspberry Pi Zero video camera that had launch detection. So somewhere online there's some footage of that. So yeah, it was a Pi Zero with a camera module and some stuff. It was very cool.
That is awesome.
That is very cool. So speaking of cool, Les, you have been looking at some coolers that are designed to keep your Raspberry Pi 5 from getting too hot.
That was the slickest segue. That was
good. Wasn't it? That's the slickest one we've done this whole series.
Best ever, of course.
Yeah, now I've got to live up to that coolness and continue on the coolness. So this is all going to go wrong, clearly. But yeah, I've been messing around now for 3 weeks now with Argon 40's latest line of Pi 5 coolers. So I'm going to go to the overhead. And this is the latest one they've got. This is the Argon Thermal 60 RC. It's not radio controlled, don't worry. That's a 60mm fan. I've got it on all the time at the moment for doing some experiments. And it's keeping this Pi 5 nice and cold. So it connects using the standard fan connection power connection just down here. And it connects to the 2 mount points used by the active cooler as well. So you've got 2 points there to connect. It cools the PMIC, the power management IC, which is just, I'll use this one as a prop, it's a bit easier. Just there. And it also cools the sock, which is just underneath here. It doesn't cool the RP1, which is the South Bridge, which does all the GPIO work these days. But it's a lovely piece of aluminium, this. It just looks the part. The black version's really nice, but it's really hard to photograph, so we're going with silver this time. Lovely piece of kit. And this is the 3rd or 4th product I've reviewed from them. So I've got, if I just go out of shot for a second and grab it, I've just finished the Argon 1 V3, which is this thing here, which is the Pi 5 version of the case for the Pi 4 here. So this has got a cooling fan. It's got a big hunk of aluminium in there as well to keep it cool. But it's also got NVMe on the base of it, so I can put NVMe hard drives in. That's about $50, that one. Can't remember the price on this one at the moment. I'll have to remember that for next time. And we have something a bit cheaper. He says, looking around his desk for the smallest box possible, which it comes in. There it is. That's Argon's, let's get it the right way around, Argon's version of the active cooler, which looks very similar to the official Pi one. All of these are different price points for different uses. So this is just there to keep your Pi cool. Great. Nice and cheap. I think it's about $5.50, $6. Then we go to the top end of the scale, $50. But this is cooling and an NVMe drive all in one. So it's all nice and neat. And none of that, as on these, where you have to use USB 3 and a pass-through connection, just there. It's all built in straight to the PCIe connection on the Pi now. And interestingly, I certified this last week. I'll get it right way around this week. There we go. RP2040. It's got a Raspberry Pi inside your Raspberry Pi. Cue the meme. So yeah, it has a Pico in there that's running the fan and temperature control. So it just say, right, how hot is it? Oh, right, I'll turn the fan on now. It's brilliant. So that's a little cooler there. I say little, it's huge on top of the Pi. It's decent. It's not as extreme performance as the 52 Pi water cooling kit that I was testing a while back, but that was $120. This is a lot cheaper. I think it's about $30 or $40 maximum for this, and it does a similar job. A little issue I found out with this and Pi fan cooling in general. So the Pi has trigger points for the temperature, so the fan will turn on when it gets to a certain temperature. You don't want it on all the time because it can get slightly noisy. But I wanted it on all the time because I could not trigger the fan to come on. The heatsink was that effective. It was cooling the Pi passively all the time. So I had to forcibly start the fan. And there's a command in the terminal that you can use to start the fan. You set it to 4, which is full speed, and it just goes, no, I'm not going to turn on. Something in the background just goes, hang on, the fan's on. Is it hot? No, turns it off again. It just overrides what I'm doing. But I found that if I set it to 1, which is about 25% speed, I can get the fan on all the time. You can see the fan's on right now. I just stop it. Don't do this at home, kids. There you go. it's on all the time. And it's just blowing gentle air across the heatsink. And I've got some really good results. I'm not going to share them. They're going to be in the review. That's a spoiler. But I've got some really good results for temperature on this, even at overclocks of 3 gig. But yeah, that's what I've been doing for the last 3 weeks now, testing various Argon coolers.
Nice.
Wow. Yes. They're so good you don't even need to use them.
It's like a reviewer's nightmare, isn't it? It's like it works so well. It doesn't. I can't review it.
Yes,
it's never on.
I've been in the staff chat for 2 days now saying I can't get the fan to turn on.
I mean, that's an argument that you don't need it. I mean, I guess the question I always have about these super duper coolers on Raspberry Pi is like, if the throttle point is 85 degrees or 80 degrees Celsius, and you're not even coming close to that point, why do you need to get an even bigger cooler? Because it's not like there's an overclocking ceiling, right? It's like 3.1, isn't it? Like you can't go.
The overclock ceiling is 3 gig, and that's confirmed by Raspberry Pi's hardware team.
It's 3 gigs, so you can't. So it doesn't matter. You could have like liquid nitrogen or something, and you still wouldn't get more than 3 gigahertz. So why bother? Unless there's some kind of a custom firmware that you could get that would allow it to go over 3. But obviously, this wasn't designed for that. So
exactly.
I mean, I would personally love to do that. Like, you know, if I had liquid nitrogen and I could try see what happened, but for the average for the person buying this, like they don't need it. Like I don't get, like, you need cooling unless what you're going to get is quieter. Like, is it going to be significantly quieter than the stock fan because it's bigger?
Yeah, when it gets to about 60 degrees C, the fan turns on to about 40% PWM, and you really can't hear it. On the stock one, right camera, there we go. You can hear a very, very faint whistle. On this big one, it's slightly louder, but it's not obscene. You got to remember, I'm sitting about 50 centimeters away from that,
right?
And I can just hear a faintness when I haven't got the headphones on. Something like the V3, because it's got a huge bit of aluminium and the fan, the aluminium soaks the heat into the case, and it's quite effective. And the fan's buried deep inside of it, so you don't really hear it.
I mean, I kind of dig that one just as a case. It's a nice thing, isn't it? If you're kind of carrying if you want to transport your Pi 5 around, or you just want it to look nice on your desk, it's a nice object, isn't it?
Oh yeah, I mean, this one, absolutely lovely case. My criticisms are, let's get them out of the way first of all. Fingerprint magnet.
Okay.
It's a matte finish, so when you put your fingerprints on sweaty hands, you're going to see fingerprints, sweaty, greasy hands all over. Also, because it's a matte finish on the case, it does scratch easily. I've got one scratch on it just around here where the GPIO port is, where you can't avoid it because you're putting this thing on and off to get to GPIO. You're going to scratch it. The old one had it's not, but it had like an enamel finish to it, like a glossier finish, where that's matte. As you can see, a different color there. They both look pretty much the same. But as a case, fantastic, because you've got all the ports broken out. You've got big HDMI ports, which are always handy, because I find the micro ones just a bit too small for me. You've got audio composite jack out there, and then you've got what I've been harking on about, that little slot there for your NVMe. So you can put 2230 to 2280 size drives inside there, NVMe, put them in, that's a heatsink, away you go. So for $50, that's a good case.
Yeah, yes it is. Well, folks, it's going to be very exciting to see the full story behind these. I strongly recommend to everybody to check out the StoRPer on Tindy. Get them one. Put yourself on the wait list. Get them when you can. Get them when you can, because it's a fun robot platform for a very affordable price.
Yep.
Thank you so much to Jo for joining us today, and to all of you for watching and listening. We'll be back next week at 2 o'clock US, 7 p.m. UK time.
Hang on, UK, 6 p.m.
Oh, wait. We're 6. You guys haven't switched to the daylight.
We do it on the last Sunday in March, so there's 3 weeks where it's going to be
we
weird.
did it all. I thought you had done it already.
No.
Oh, you see, this is the problem, right? We should all be on Swatch Beats time. Then there wouldn't be any problems, would there? So
I always have a panic in the UK when all the US people online say, "Oh yeah, I saw a joke the other day about, happy temporal disturbance day," and I was like, "Oh my god, have I missed it?" And then I always realized, no, it's US have changed.
Yeah, this is what I dislike the most about time zone changes, because we're not even in sync with the rest of the world, which is bad. So 6 p.m. Sorry, next week, 2 p.m. US time. We will see you all then with another special guest, and we'll talk to you soon. Bye, everyone.